Welcome back to Matt's Automotive Channel. In our previous video, we were trying to recharge the AC system on this 2001 Mustang because the AC compressor was not coming on. And when we checked it with the gauge, it had no pressure on it, so the assumption was we was just low on Freon and we may have had a leak. Well, we didn't find any leaks, and we proceeded to put some Freon in, and the AC compressor still didn't come on. So after a few diagnostics, we determined that the problem was with the CCRM module, which is located right here under the front right side wheel. And CCRM stands for a constant control relay module, and it's responsible, there's various relays on this board, and it's responsible for the cooling fans and the AC compressor and the fuel pump. So anyway, we went ahead and ordered a new relay to replace on this circuit board, and we just got it in. So let's go ahead and solder it in and see if we can make this thing work. All right, so in the previous video, we went ahead and removed the relay, and you can see a little bit of discoloration here on this backside of the circuit board, which indicate that it had gotten hot. And this is the relay that we pulled out. It was even kind of bubbling up here on the surface. I tried to get a new relay online, and there was a few part numbers that cross-reference this. However, when I placed the order, never showed up, so my assumption is they no longer make that part. So I went ahead and just found another relay that was close to the same dimensions and had the same specs. So if you look at the bottom side of these, this relay that we're going to use is physically a little bit smaller than the one that came out. However, the pins are still the same distance. They're designed to go on a PCB board. So anyway, let's go ahead and solder this in and see if it works. This is, by the way, it's a 12 volt, 10 amp at 250 volts, or 15 amp at 125. So let's give this a shot. All right, I ended up getting 5 relays for about 10 bucks, so about $2 a piece. And they are a 5-pin relay. And in case you're wondering, the way that it works is the side with the 3, these 2 outer sides are power and ground. And then from this middle pin to one side is normally open, and then the other side is normally closed. So when these 2 outer pins here on this side are hit with a voltage, the one that's normally open goes to closed, and the one that's normally closed goes to open. So it just toggles power between these 2 and these 2 pins. Normally you would see this kind of relay for a high beam, low beam, so power is either going to a low beam or a high beam. I'm not exactly sure why we're using a 5-pin on an AC pump, but maybe it's constantly passing power to one side or the other to let the computer know that there is power going to that board. Just a guess. All right, in putting this board together, when I pulled it apart, this PCB board was riveted to this back plate here using these 2 pins, and then this cover went over like so, and then riveted the back plate to this cover here. And then, of course, we have the bracket. Let's see, right here. This gets mounted to the car, and then this gets mounted to the bracket. The thing is, without riveting this back to the board, I put this on, and I think if we just rivet these 2 pieces together, it's pretty solid. It doesn't shake or vibrate or anything, so I don't think I'm going to bother riveting the board to this back plate. I think I'll just rivet these 2 plates together using these 2 holes, and hopefully that should be good enough. I'm going to rivet this box back together using these rivets here. They're 1/4 by 3/16, and if you look here, they're just long enough to go in, and they don't go to the sink to the bottom of that hole, but right there, and then comes up right here, so it'll flare out, and that should hold it in. So I'm going to use these 2 guys to secure the box back together. Perfect. We do the same thing on the other side. Perfect. Box is being held together real well, and we can always drill these back out again if we need access to the inside. And as you can see, there's nothing rattling around in here. So I think this will work just fine. All right, now we can bolt the bracket back on. Let's go ahead and remount the CCRM. These again are 11mm bolts. And secure these before you plug the harness in, because this will block access to that bolt. Okay, and then this little bolt here is a 5mm. Okay, so we have our AC manifold hooked up again. So let's add a little more refrigerant and see if our AC compressor kicks on. All right, so I just went ahead and opened up the valves, and you can see we still have pressure here from our previous attempt. So let's go ahead and fire it up and add a little bit more. All right, we definitely have plenty of pressure in there. We have about 40 psi, so that should be kicking it on, and it's not. So let's go ahead and short out the low pressure switch again and see if we can get it to go. There's the fan. There we go. Now we have power to the pump. So it looks like we may have an issue with our low pressure switch. Alright, so we're going to manually turn it on. And then look at that. Everything does really well. So I think we have another problem here. The two apparent problems that we had, one with the low pressure switch and the other with the high side pressure going down when the compressor kicked on, are now resolved. The low pressure switch, when I disconnected the electrical connector from it, I heard a little click. And so I think what had happened is it was just sticky, probably for a few years of no use. And so anyway, that's cycling on and off perfectly right now. As soon as the pressure comes back up to 25, 30, it kicks back on. And the deal with the high side of the system going low was just due to the fact it didn't have much refrigerant in it at that point. And what was happening was that as soon as the compressor would kick on, it would start converting out, the gas into a liquid. And since there wasn't very much in there, it would decrease the volume in the system. So that would create the low pressure on both sides. As soon as I added more refrigerant, we started creating more pressure on the other side once we had some Freon to work with. And so anyway, that resolved itself as well. So everything is working the way it should here. No apparent leaks. Everything looks good. All right, so we're ready to add our last can, and we only want 10 ounces of the 12 that are in here. So I'm going to turn it on, tear the weight. Alright, now we're putting it in. You can see it going down. So when that gets to 10, we'll turn it off. Alright, we've added all the refrigerant that we need, and you can see our gauges here. We've stayed at 30 on the low pressure side, and between 175 and 200 on the high side. And you see compression running like it's supposed to. So we go ahead and close our valve now. Close these guys, and then disconnect it. And then we'll take the temperature on the inside, see if it's blowing cold air. All right, certainly feels like it is, so let's take a temperature here. Looks like we're right around 45, 44, 43, 41. So we got the system working again. The ultimate problem here was the relay, AC relay in the CCRM, which is the constant control relay module. We were able to just put in a new relay switch, and then that took care of the problem. So everything looks good. It's blowing cold air, no apparent leaks. So I guess we'll call it quits at this point, and I'll catch you on the next video. Bye-bye.